Hello and welcome to this presentation on XML External Entity Injection. I am Toberius, and I'd first like to thank the organizers of OnlyFeet Con for actually accepting this talk. It was very generous of them. Okay, so let's move on. Why isn't this working now? There we go. Okay, so if you aren't aware of who I am, I've been a web app pen tester for about 10 years. I'm currently working full-time in that capacity. I'm pretty active on Twitter, and I have a number of my other accounts, such as my YouTube and Twitch channels linked from there, so please consider giving me a follow. Now, unfortunately, my foot did slip when I was typing my username, so you have to put Tiberius instead of Toberius on Twitter. I do apologize for that. I am also the proud owner of Only 2 Feet. So I don't want to assume anything about our viewers here today. If this is your first time hearing of XML, then this slide is for you. XML stands for Extensible Markup Language, and it is a standardized way to store structured data, which is both human and machine readable. XML documents are comprised of elements or tags, starting with the root element, which in this case is called foot. And then tags can contain other tags. So here's a toe tag, for instance, or text values. So this is a text value pinky, and this is a text value big. Tags can also have attributes. So this tag here has a nail color equal red attribute. I've skipped over these 3 lines here, and that's because they're usually optional. This is a doc type definition, or DTD, and it can be used to define the structure of the document so that a parser can determine if the document is well formed or cannot be validated. When an XML document is parsed by a computer program, it generates a document object model, or DOM, which can then be queried programmatically to extract data from the document. For example, when this XML document is passed into a document object model in Java, this code will extract the root element name, which is obviously foot. This will extract the value of the first toe element, which is pinky. And finally, this will extract the value of the first attribute of the second toe element, which is red. Moving on. So let's talk a little bit about XXE injection. XXE stands for XML External Entity. So yes, the second X actually stands for external, which makes no sense. Don't actually ask me why, I don't know. But we will see that these entities, what these entities are in just a moment, but I want to highlight why XXE is such a fun vulnerability. XXE injection can lead to all sorts of other vulnerabilities. You can include local files, local here meaning from the server. You can perform server-side request forgeries, which can also result in remote file inclusion too. Some of these attacks can be performed blind, and later in the presentation, we'll perform some data exfiltration using blind methods. In some cases, you can also turn an XXE injection vulnerability into a denial of service attack, and in some rare cases, you can even achieve full remote command execution. Okay, so what are entities then? Well, let's say we want to have a tag in our XML document with the content "I love feet" using the heart emoticon. If we write it out normally, this document will fail to parse because when the parser sees a less than symbol, it expects that to be the start of a tag or a closing tag. To get around this, the designers of XML came up with the concept of entities, which are string representations of specific characters. There are 5 predefined entities in the XML spec: the quotation mark, the ampersand, the apostrophe, and the less than and greater than symbols. Entities start with an ampersand, then the entity name, and finally end with a semicolon. So when we use an entity representation of the less than symbol in our XML document, it will look like this, right there. And now when the XML parser reads the value of the tag, it will convert the entity back to the character in its document object model. Okay, the XML spec, though, doesn't stop at 5 entities. It allows anyone to declare custom entities within a doc type definition, the DTD. There are 2 types of custom entities, internal and external. Internal entities represent data that is contained within the document itself and is defined as a string. External entities represent data that is located outside the document and is defined as a URI, a Uniform Resource Identifier, which points to the location of the data. Crucially, however, the XML spec says absolutely nothing about which URIs are valid or how they are even processed. It leaves that entirely up to the XML parser. A key point to remember about custom entities is that they are only fully expanded when they are needed by the parser. For example, if you have an external entity which is defined as an HTTP URL, the parser will not fetch that URL when the entity is declared, but instead if and only if the entity is actually referenced within the XML document. So here's a quick example of an internal entity. We have the entity toenail defined within the doc type, and the data represents is the string sum string. When the toenail entity is referenced in the XML document within this tag, the XML parser will then just convert it to sum string within the document object model. I want to pause here and just say that this is absolutely fine. This makes perfect sense. It's actually very useful. For instance, if you have to reference the same long string multiple times in the same XML document. Internal entities, when used like this, can actually save space in the document, and there's nothing inherently vulnerable about internal entities when used like this. Moving on, let's talk about recursive entities. So yes, entities can reference other entities. So this is a simple case. We have the same entity toenail declared as the representation of the string sum string, but then we have a second entity toenail 2, which declares the representation of the string this is, and then a reference to the toenail entity. So when toenail 2 is used within the document, the parser recursively expands the toenail entity as well, and the result is the string this is sum string. Again, this is fine. This kind of also makes some sense. However, this is just one level of recursion. What happens if we keep going? Well, let me introduce you to the billion toes attack, which is based on a real attack that involves laughs instead of toes. You can Google it. It has its own Wikipedia page. But we start by declaring the entity toe as just a string toe with a space after it. Next, we declare the entity toe1 as a string containing 10 references to toe. Then toe2 with 10 references to toe1, etc. We continue this all the way down until we get to toe9 with 10 references to toe8. So when we reference toe9 in the document right here, the XML parser is going to recursively expand these entities, and we end up with a string of 1 billion toes, which is where the attack gets its name. This uses up about 4 gigabytes of memory. And when you consider that the payload is only about 784 bytes, this is both an amplification and a denial of service attack. You can, of course, keep adding rows, and every time you do, the resulting string increases in size by a factor of 10. So let's talk about external entities now. To declare an external entity, you need to include the keyword system after the entity name in the declaration, and then provide the URI which points to the data. So in this case, we have Footpics for Sales OnlyFans link. So what happens when the toenail entity is referenced in the document? Well, that all depends on the parser, but most will issue a GET request to that URL, download the contents, and then store it in the DOM. Of course, HTTP is not the only scheme that can be used, and depending on the parser, there could be any number that you can take advantage of. A very common one is the file scheme, which can fetch files that exist on the operating system. But there's no reason why other schemes like FTP cannot be used. If the XML parser is PHP-based, then PHP filters can be used, which can allow for encoding of certain binary files as well. And if you remember at the start of the presentation, I said that sometimes you could get remote command execution. Well, if the PHP expect module is installed, then the expect scheme can be used to execute commands directly on the OS. Okay, so let's take a break and do this first lab. So we're going to do this on Portswicker, by the way, which is free, their Web Security Academy. This lab has a check stock feature that parses XML input and returns any unexpected values in the response. To solve the lab, inject an XML external entity to retrieve the contents of the /etc/password file. Okay, so let me just switch out here. And I believe this is the right lab. Okay, so we're going to load the lab. I am already proxying it through burp. Okay, so if we go here to the first, let me zoom in. We go here to the first product and scroll down. We see there's a check stock button there, which if we click and go here, we can see, actually, let me just adjust the font size a little bit here. I think that's probably better. Okay, so we'll send that to repeater and click send again. So we see it has this XML document here. So let's put in a doc type. And I've got one pre-prepared over here. So the doc type goes after the XML tag and before the actual document. But here we have a, we have the doc type called foot, the entity toe, which is a reference to the file etc password. And then all we need to do here is change the product ID from 1 to a reference to toe. And then if I click send, we get invalid product ID and then the entire contents of the password file. Okay. Let me switch back to the slides here. So let's talk about parameter entities. They are a special kind of entity which can only be referenced within a DTD. You can change regular entity into a parameter entity by simply adding a percentage sign before the name in the entity declaration. So right there. Note that you can do this with both internal and external entities. This can sometimes be useful when regular entities are blocked. However, as we shall see, they also come in handy when we have blind XXE and need to exfiltrate data. The example here declares an external parameter entity called toenail, which represents data located at that OnlyFans URL again. Immediately after the entity is declared, it is referenced within the DTD right here, meaning that the parser will issue a GET request to that URL. Within the XML document itself, but a DTD can also be hosted externally somewhere in the document. The parser will fetch the external DTD and use any declared entities within it if they are referenced within the document. If you have the following DTD here located at onlyfeet.com/toes.dtd, you can reference this external DTD in a couple of ways. Firstly, by declaring it in the doc type tag itself, and secondly, via a parameter entity, which you then reference explicitly. The external DTD in this instance declared the entity toenail, and so this entity can then be referenced within the document without errors. So we've looked at XXE vulnerabilities where the entities injected were returned in the response as the data we wanted to extract. However, you are likely to come across blind XXE vulnerabilities where nothing of value is returned in the response, even though the XXE is being triggered at the backend. A combination of external DTDs, parameter entities, and dynamically declared entities can exfiltrate data in these cases. So here we have an external DTD located at onlyfeet.com/malicious.dtd. It declares an XML parameter called file, which is going to load the contents of the hostname file. This line declares an XML parameter called an XML parameter entity called eval, which represents a string containing the declaration of another XML parameter entity called exfiltrate, which, when referenced, will trigger an HTTP request to onlyfeet.com with the value of the file entity in the URL query string. And we know that should be the contents of the hostname file. The eval entity is then referenced, which causes the exfiltrate entity to actually be declared. And then finally, the exfiltrate entity is then referenced, which causes the HTTP request to be sent. So the payload in this case simply declares an XML parameter entity called XXE, which loads the external DTD and immediately references it. One potential limitation here is that sometimes you cannot exfiltrate more than one line in a file because the parser may refuse to send new line characters as part of the URL. This is why we used the hostname file in this example. Okay, so let's do lab 2, which is XXE with out-of-band exfiltration. This lab has a checkstock feature, again, which passes XML input, but does not display the result. To solve the lab, exfiltrate the contents of the hostname file. So let's exit out of this, and we will go to this lab here. And start it up. Okay, this has an exploit server. So the first thing we're going to do is go to the exploit server and put this DTD in. Again, this is pretty much the same DTD we saw in the presentation. I'm just going to replace this with the hostname of our exploit server itself, which is found up here. And then I'm going to change this to exploit.dtd and click store. Okay, now we're going to view the details of the first product and check the stock. And if we're lucky, it should be down here. So we'll send this to repeater again. And then what we will do is just put, again, this stock type in. We do need to replace the URL again. So grab this. Okay, so it's creating a parameter entity called toe, which references our external DTD and then immediately calls it. So if we click send here, we'll get an XML parsing error, but with any luck, if we go back and go to the access log, we see that it did indeed get the Java here. This is obviously a Java parser. Got the exploit.dtd and then made another GET request with x equals, and then this is the host name. So if we submit that, we solve the lab. Okay, let's go back. So sometimes we'll find a blind XXE that still reports errors back to the front end of the web app. And in these instances, it may be possible to convert the blind XXE into a non-blind XXE by intentionally triggering an error and manipulating it so that the error message actually contains the data that we want to exfiltrate. So again, in this example, we use an external DTD at onlyfeet.com/malicious.dtd. We declare an XML parameter called file, which is going to load the contents of the password file. We then declare an XML parameter entity called eval, which represents a string containing the declaration of another XML parameter entity called error, which is going to try and get the contents of a non-existent file path. And if you notice, the file entity is referenced, which means that the entire contents of the password file itself is going to become part of the file path being requested. The eval entity is then referenced, which causes the error entity to actually be declared. And then finally, the error entity is then referenced, which causes the parser to try and load the contents of the non-existent file path. And when a file doesn't exist, the error message itself sometimes contains that file path that was requested. So with any luck, the error message should contain the contents of the password file. So let's do this again. We have lab 3, the final lab. Again, we have the check stock feature. To solve a lab, use an external DTD to trigger an error message that displays the contents of the password file. The lab contains a link to an exploit server on a different domain where you can host your malicious DTD. Okay, so let's go and do that. I'm going to load the lab here. Let's close a few of these tabs. Okay, we'll start the lab up. Okay, the first thing I'm going to do is go to our exploit server. And we're going to call this exploit.dtd. And we're going to use the same DTD that I showed in the presentations. There we have the file non-existent with the file parameter there. That's all we need to do. We can store that. Then we can go back here, view the first product and check its stock. And then we'll send this to the repeater. Make sure it still works. Good. Okay, now all we need to do is put in our doc type, which again just declares the entity parameter entity toe, which is going to refer to our exploit server with the exploit DTD and then call it. So all we need to do is change this. Go back to our exploit server and grab the host name and put it in here. And if we click send, we get an error message, XML parser exited with non-zero code 1. So you see here's the file path / non-existent and then / basically the entire contents of the password file. Okay. We get a no such file directory error down here. All right, so that was my presentation. Thank you very much. Has anyone got any questions? Is infinite recursion allowed, e.g. toe1 references toe2 and vice versa? That's a good question. I think most parsers won't allow that. It does depend on the parser though. But yeah, I think infinite recursion generally isn't supported. With XOC, is it possible to make APIs that use JSON except XML with an injection? I guess it depends on the API being used. I know that I think one of Portswigger's labs has you turning not exactly a JSON object into an XML object, but it has you converting a regular HTTP form into an XML object. But I really think it depends on the actual setup. So I think I don't know of any servers that do it by default, but it might just be a weird configuration option to accept JSON objects and XML documents. Okay, does Burp have free courses? Yeah, so Portswigger Web Academy, Portswigger Make Burp, and those 3 labs that I showed were all free. The entire academy is free. Some of the labs do kind of require you to have Burp Pro, but honestly, it's like maybe 1% of them. Other than that, every single lab in there is completely free and doesn't require you to use any other software. I read a paper that had the evidence this could be done. I was just wondering if you've seen it in the wild. Yeah, I've seen it loads of times in the wild. It's generally the default parser configuration to enable entities. So if you're a programmer, you use some XML parsing library without realizing that you need to disable entities, or at least disable external entities and recursive entities. So yeah, I've seen it multiple times in the wild. Is XSE so dangerous because it's a stateless language? I don't think necessarily it's dangerous in that respect. I think it's just dangerous because XML is still pretty commonly used, and again, like I said before, the default configuration of the parser is to enable entities. So if you run into XML parsing in the wild, even if you're using it like XML is just a regular config file for a thick client, that can still be vulnerable. How do we mitigate this? Refuse outbound connections to OnlyFeet.com and OnlyFans. Yeah, I mean, that's one way of doing it. As we all know, attackers basically mostly host their files on those two sites. But seriously, yeah, to mitigate this, it's actually pretty easy for considering how serious it is. All you need to do is, at least for most parsers, is turn on a few configuration options. Usually, if you're lucky, the parser will keep entities and external entities separate options. So disabling external entities won't disable internal entities. And if you're really lucky, you can also disable recursive entities separately as well.
Thank you so much, Toberius.
Thank you. Thank you for having me.
Yeah, this is good. We've worked out most of the kinks, it seems like.
All right. Thank you, everybody.
Thank you, Ted.